Now you should be pretty comfortable with the basic identities, and it's time to start incorporating some higher level formulas to help us work with identities and just with trig functions in general. So you should have written down the sum and difference formulas and already taken a good close look at them. This example is going to show you how we can evaluate a trigonomic expression or its trigonomic function for an angle that we don't already know, based on what we do know. So let's calculate the exact value of sine of pi twelfths. Now, we don't know what pi twelfths is. It's not on your circle, and I hope you haven't memorized it because we don't know an exact value for it. However, we can figure out an exact value based on a little bit of information. Information piece 1. Pi twelfths is pi thirds minus pi fourths. If you're not comfortable dealing with fractions, it's just going to be a matter of guess and check. We don't stray too far, so you're going to have to get comfortable with this if you're not. And the other piece of information that we're going to use is our formula for sine of u minus v. Now, that formula says that sine of u minus v equals sine of u times cosine of v minus cosine of u times sine of v. As far as we're concerned, this means that we've got the sine of pi thirds minus pi fourths. If we plug in this information where it matches, we will have sine of pi thirds times cosine of pi fourths minus cosine of pi thirds times sine of pi fourths. And the difference between this expression and sine of pi twelfths is that we can evaluate this expression because it's comprised of information that we already know. So, sine of pi thirds is square root 3 divided by 2, cosine of pi fourths is square root 2 divided by 2, minus that 1/2 for cosine of pi thirds, times square root of 2 divided by 2 for sine of pi fourths. And voila! We know exactly what sine of pi twelfths is. It is the square root of 6 minus the square root of 2 divided by 4. Notice, please, when I combine those fractions that I did not combine items under the radical. You cannot do that when things are subtracted.